All right, let's take a look at volume of pyramids and cones now. Again, volume is how much we're filling up, like say with a liquid or sand or something of that sort. So we're going inside 3 dimensions. Now, your volume of your pyramids and cones, I will go ahead and let you know, is actually going to, like your pyramid here is going to be 1/3 of the volume of a prism. Okay, you can fit, if you fill in a pyramid that has the exact same base and height, and you fill up a prism with the exact same base and height, you can pour 3 of the pyramids into a prism, making it 3 times. So, or the pyramid will be 1/3. So here we'll have our volume equals, instead of putting the 1/3, we'll just divide by 3. And your formula for volume of a prism was area of the base times height. So we're just going to take the area of the base times the height and divide it by 3. So let's take a look over here. Our base right here, we see the 10 and we don't see any other markings, so we're going to automatically know this is a square. So big B, the area, with a square, we want to do the side length squared. So big B is going to equal 100. Now we have to find the height. When we take a look at the height here, though, we don't have it, so we have to call up our good friend Pythagorean Theorem. All right? We draw this triangle to the side. Here we have our height. Our hypotenuse is 13. This other leg is going to be the height goes from the tip vertex down to the center of the square. So it's going to cut it in half, so this will be 5, half the side length. If you know your triples, you already know what the height is. If not, let's do Pythagorean Theorem. We have h squared plus my other leg 5 squared, all equal to my hypotenuse of 13 squared. This is where I'm going to ask you to pause it. Work the rest of it out. Make sure that you get the correct height. I am pausing it, and the answer is about to show up. Please, 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 pause it now. We should have found out the height of our pyramid is going to be 12. So now let's go ahead and plug into our formula. We have over 3. We have our area of the base, 100, times our height of 12. And we can plug this all into the calculator at one time. Do be aware, because we're divided by 3, sometimes we may end up having a decimal. We'll round to the nearest tenth if so. This one will come out to a complete whole number. It should be 400 units. Again, volume is 3-dimensional, so we need an exponent of 3 cubed. All right, on the next one, very, very nice of us to give you the big B. Okay, usually we try, unless it goes above quadrilateral, we won't give you big B. But here we're giving you the base area of 249.6. So big B will be 249.6. And we're giving the height of 16. So right here, the height is going to be 16. We plug into big B, 249.6. times the height of the pyramid, 16, divided by 3. We will get a decimal. We have a decimal in the numerator anyway. We're going to wind up with a decimal, round to the nearest tenths, 1,331.2. And we do have inches on this one, so we'll have inches cubed. Next, your hexagonal pyramid. Okay, it even tells you it's a regular hexagonal pyramid. We're giving you the base area, so big B is 93.5, and your height right here, height of 13 centimeters. So we gave you everything. You just have to plug in. You have to make sure you're using the right formula too. We do have area base times height divided by 3. So big B, 93.5, times the height of 13 divided by 3. Be prepared and on the lookout for a decimal here. And we will have 405.2. We have centimeters, so centimeters cubed. So let's take a look at the cones. The cone, just like the pyramid, the cone is going to be 1/3 of a cylinder. Okay? And in our cylinder notes, we learned that the formula for a cylinder, for volume of a cylinder, it was pi r squared times the height. So here we will have the volume is equal to that pi r squared times height over 3 because we want to divide it into 3, 1/3. So first things first, we see here that my radius, I've given my radius, sweet, don't have to do anything, 15. Now my height. The problem is I do not have my height. This is what I need. So we're going to have to use Pythagorean Theorem using our slant height and our radius. So here we have our height that we're looking for. We have our hypotenuse, which is the slant height, and we have the 15. So again, h squared plus 15 squared, be ready to pause it, equals 25 squared. Pause it now, work the rest of it out on your own, and then resume. We should have found our height to be 20. So we fill that in up here. Let's go ahead and plug into our formula. We're going to have, in the numerator, we're going to have pi times our radius squared, so 15 squared, times our height that we found was 20. Again, we do have this, over 3, because we want 1/3 of it. When we do this, we do have pi. We will always have a decimal, because pi is an irrational number, decimal that continues on and on forever without repeating. So we're going to round to the nearest tenth, being careful with our rounding. When we plug this all in, whether it's before or after I get the answer, hopefully you have done it on your own, practicing with that pi, 4,712.4 units cubed. All right, next. Here we do not have our radius, so we're going to have to go find our radius. All right, go off to the side. We're going to use our Pythagorean Theorem. I'm kind of drawing a sloppy triangle here, but draw it off to the side. We have our radius we don't know. We have our other leg, the height of 45. And then our slant height that we use in surface area, okay, our hypotenuse is 51. Let's fill it out. R squared plus our other leg, 45 squared, is equal to that 51 squared. Please pause it, get caught up, solve it, resume to see if you got the correct answer. Pause it now, please. We should have found our radius to be 24. Okay, and again, here we already have our height of 45. So let's plug into our formula. We're going to have pi r squared h on top and the 3 on bottom. So here pi r squared, radius squared, 24 squared, times the height of 45. We're going to calculate all of this and round to the nearest tenth. This will be a very large number. Okay, look how big those numbers are. Okay, we're going to wind up with 27,143.4 units cubed. A very large number. A lot of times 1,000, I'll put a comma, but I want you guys to see there are 5 digits before that decimal. Last one. Okay, radius, problem is, they gave us the diameter on this one. So the diameter was 14.8. Split that in half to get our radius of 7.4. Cross off that diameter. We don't want that. So we have 7.4. Our height, okay, again, we do not have. So let's check this out. We have the slant height. We have the radius. We need to find that height. Okay, so I'm going to draw that triangle exactly as it is. Okay, just so we see it the exact same way. We have our 90-degree angle right here. We know our radius right here was 7.4. We know our slant height, also going to be our C or hypotenuse, is 15. We're looking for our height. So let's go ahead and plug in with our Pythagorean Theorem, pause it, and figure it out on your own. So h squared plus 7.4 squared is equal to 15 squared. Pause it now, please. Put everything in your calculator, figure out what we have. Pause now. So what ended up happening is, because we have this decimal, we have to square. We wound up with the decimal taking the square root of, but this will come out to approximately 13. Okay? So we're going to go ahead and use 13 as our height. Almost done, guys. Plug this in. Denominator, we're going to have that 3. In the numerator, pi r squared h. So pi, r was 7.4, so 7.4 squared, times h, which we found was 13. You bop that into your calculator, right? Round to the nearest tenth. We should get 745.5 centimeters cubed. And there are your pyramids and your cones for volume.